Good morning, everyone. Thank you so much for having me here. Thanks to Thunderhead Engineering also. My name is Mohammed Saeefan, and today I'll be talking about bridging the pre-movement and movement data gap through non-fire protection studies. Just a brief introduction about me. I have a bachelor degree from University of Leeds in the United Kingdom in fire protection engineering, and I have a master's in University of Maryland, College Park. I work for Saudi Aramco oil company in Saudi Arabia. It's the biggest oil company in the world. And I think it's not working. Okay. So basically, I'll be looking at other non-fire protection disciplines and what studies have they done and try to build on them in the models we do in fire protection engineering. So, and I've done a simulation at the end to show how we can benefit from it. So initially, I'll go through the current situation and data gaps we have. Examples of available data from other disciplines such as civil engineering, traffic studies, medical studies. Then I'll show you a Pathfinder comparative analysis comparing SFPE data to one of the studies I've gone through and future area of improvements. The current situation is many of the studies in Non-FPE and SFPE assumes people are homogeneous, which means able-bodied people alone and disabled alone, and they do not consider them heterogeneous, which are mixed occupancies. So, and pre-movement and movement studies done on some disabled people. And here's an example from, I think this is Non-FPE or SFPE. So the number of disabled people in this table is only 107. So that's not considered a significant number to do a study or a model on it. Pre-movement examples in Non-FPE give examples on hotels and office buildings. What about other types of buildings? So the current situation, as I said just now, is in reality people are heterogeneous. And there is a huge lack of data in pre-movement and movement. You can never have enough data to perfect and make your model more accurate. And data are very old and consistently changing. For example, many of the data used is Fruin 1971. Important thing here is to focus on how the data was obtained and the quality of the data. So that's a major, it has a major impact on the model or the evacuation study you're doing. So the several factors you need to take into consideration are two factors, human-related, building and environment-related. So for the human ones is the health, size and weight, and the cultural effects. Each country has its own cultural effects and huge difference in the evacuation numbers. For the building and environment, geometry plays a major role, the design of the egress path, and the weather. For example, Saudi Arabia, we're either 50 centigrade hot or 0 in summer or winter. While here in DC, I've lived here for 2 years, you see all seasons. I mean, it's hot in the summer and freezing cold in the winter. So the non-FPE studies, I'll be going through civil, traffic, medical. Let me start with the first one. This is a great study done by Utah State University by the Civil Engineering Department. So they studied the behavior of vulnerable population in various built environments. And they've also went through the studies done previously and in their study. It's a lovely study. So they've compared other studies to their study. So they've analyzed walk-in speeds and difference between homogeneous and heterogeneous crowd. They've built a circuit 3,000 feet squared, and they've tested 202 people. 22 of them was disabled and 180 was non-disabled. So here's some examples of the experimental areas they've done. And they've tested different geometry effects: right angle, passageway, bottleneck, any angle of the corridor. And they've also tested stairs. And they've used an existing staircase and tested 100 people, 80 able-bodied and 20 disabled, with no wheelchairs in the study. So they've used actual disabled percentage found from medical studies: 2.1% visually disabled and 6.8% ambulatory disabled. A great thing done here is they've used an advanced automated video identification tracking system. So each yellow square represents a person, and it fully tracked their trajectory over all the circuit they've built. So they've really got a great quality of data. So they've noticed a significant reduction of the mean speeds of heterogeneous population in all types of walk-in facilities, which is expected. The blue line is homogeneous and the red line is heterogeneous. So a significant reduction which shall be considered when you're designing a building and known disabled people will be living in it. So benefits to fire protection engineers is the mean speeds for disabled visually or mobility, in addition to geometry effects and the age between 18 and 64. And here's another figure they've shown. Walk-in speeds statistics for different pedestrian groups and walk-in environments. So they've done an average speed for visual, non-motorized, motorized, and without disability. And here's the speeds with the geometry effects. Moving on to another study done by University College of London in the Civil Engineering Department. They've studied the walk-in speed of pedestrians on stairs only. So they didn't take too many people to test, but it's a good study to look into. They've taken 18 elderly people with no disabilities and 15 young people. So they've compared the mean walk-in speed with data from Fruin, and they've noticed that Fruin results were much slower. So this could be an effect of the culture in the UK compared to the US. In addition, elderly people versus young people, ascending and descending with the stair gradients. So these are all great data to consider when you're designing your evacuation model. So the difference may be due to individual laboratory results versus actual facilities. So this was done in a laboratory result. And the effects from other people, like mixing with other people rather than walking alone. So the benefits to fire protection engineers is the age difference and the cultural difference. A third study I'll be talking in is done by Technical University of Denmark, Civil Engineering. They've studied visual impairment. So they've taken 57 people with ranges of age from 10 to 79 with different visual impairment levels. So they've taken single and group evacuations. They've done tests in Denmark, then they've done the test in the US, and they compared it to SFPE Handbook. So here is the results. So they've noticed, they've noticed that in the US they're faster than Denmark, and SFPE falls just in between them. And the walk-in speed in descending stairs Also, in SFPE is much higher than both Denmark and US. So their findings was people with low visible do benefit from lighting conditions. So the well lightened the building is or the corridor is, the better for them. And also they've taken many like handrails. They continue into the landings itself and having markings in the beginning or the end of the handrail. And the surface, they've suggested like surface texture difference between an evacuation path or a normal path. Fourth study I'm going over today is the traffic engineering and biological physics. So they've studied people movement in normal and evacuation situations. They've related pedestrian movement to fluid dynamics, and from that they developed a theoretical microscopic simulation on pedestrian streams. So they've developed force models that simulate real human behavior situations in normal and panic situations. So they managed to replicate multiple scenarios like lane formation, oscillations at bottlenecks, dynamics at intersections, freezing by heating, transition into corridor due to clogging. Faster is a slower effect. So they've done also related fire, they've inputted fire simulation into this. So these are all great studies. This study was done by 3 people from Hungary, Germany, and the US. So researchers from 3 different universities. And I guess I have 2 more studies than the simulation I did. So medical studies in Australia, they've studied gait speed, which is basically a type of movement people engage to get from one point to another. It's over 15 meters. You measure the time over 15 meters. It's a continuous measure, measured as straight walk and uniform conditions. So they've taken more than 4,600 studies, and they've done major quality check to make sure all the specifications are the same for the data they're studying. So they've chosen 48 studies, and the number of individuals tested in these studies are 7,000. So they've taken people to be looked at are age 70 plus, hospital, inpatient, and out of patient. So they've came up with numbers. Let me just roll through them. So the usual pays, they came up with usual pays 0.58, and the maximum pays, the percentage of females in this number 7,000, which is 63%. In acute care has also a usual pay speed and outpatient speed, all for people aged more than 70 years old. They've also compared to normal and community dwellings. They come up with great numbers to use if you're designing for these type of facilities. And the benefits that these numbers can be used in hospitals which fit these criteria. I mean, it's important to use data which suits the facility you're designing for. The final study I'll go through today is done by University of Madrid, Department of Health and Human Performance. They studied the reaction time to visual stimuli in athletes with and without a hearing impairment. So athletes without hearing impairment, they've tested 79 people, and they came up with an age and speed, and they've tested athletes with hearing impairment, and they resulted that athletes with hearing impairment was significantly, the reaction time for people with hearing impairment was much slower than normal as expected. and also shorter reaction time for males. It's just data. No difference regarding type of sport they were doing. So this is a great data for pre-movement time and hearing impairment people data. So what I've done is I've tested, we have in Saudi Aramco in Saudi Arabia a building called Al Midra. It's consisting of 13 stories with a 4,200 capacity of employees. The normal capacity is 3,100. So I've taken data from SFPE and from the first study I've shown you, Utah State University. So I've taken mean, minimum, maximum, and standard deviation, and the SFPE 5th edition handbook. I've placed both data in Pathfinder, and here is the results. The SFPE evacuation time was about 2,100 seconds, and non-FPE evacuation was about 1,700, which is actually closer to the actual evacuation is 1,200 seconds. So the non-FPE evacuation time was more accurate. Doesn't mean it's correct or not, but I'm basically showing benefit of looking at other studies and what people are doing, which may, as a student, when I was doing my studies, we never looked at other non-fire protection studies. We only focused on the fire protection studies we did. So the factors that may have affected was SFPE was uniform, inputted in Pathfinder, while the Utah State University was normal walking speed. So maybe that had an effect on it. The methods used to collect data for both studies, and the quality of data, location, and culture. One of my colleagues, he studied in WPI, he did his PhD. He did a lot of studies in Saudi Arabia and the cultural effect, and the dress also plays a major effect in females and males, the dress we used. So, but I didn't want to show his studies since it's a fire protection study, but I did run a simulation on that effect. So it's important to conduct more detailed analysis to determine the independent variable with significant effects. That's what I'm working on actually now, on determining the independent variable with most significant effect. So in conclusion, each designer shall build up his own database suitable for location he's designing for. In Saudi Aramco, we have contractors with most of the major fire protection companies. And the problem is they're all over the world, in the US, in the UK. So they do struggle in getting data that suits Saudi Aramco, Saudi Arabia, and the numbers we work with. So, and fire protection engineers need to work with other disciplines, learn from them in order to get more robust studies. Centralized data in FPE, that's, I guess, in many conferences, like they always highlighted as a concern. And finally, I want to end up with a great quote I took from Dennis Maliti. What we study is people and how people respond. It doesn't matter what the hazard agent is, the same kind of question and theories apply, whether it's terrorism, or an earthquake, or flooding, or a dam failure. So from this, when I read it, it makes sense on looking at other disciplines and not just focusing on fire protection. Thank you so much for listening to me, and I'll be happy to see your questions.